move to the next point, we should ensure that whatever we see is clear.
That means work is being done. We can see that it is in opposite direction. It is against.
My dear student, you are welcome to yet another segment of our learning. I am by name Mr. Monday Bokway, and I'm going to take you through the subject mathematics. Our topic of consideration this day is polygon, and we have a subtopic, the sum of exterior angles of a polygon. Sum of exterior angles of a polygon. For any n-sided polygon, the sum of the exterior angles of that polygon is 4 right angles. Is 4 right angles. That is 360 degrees. Mark you, my listeners, my students, my learners, that exterior simply means outside. So at any point the sides of a polygon are extended, it forms an exterior angle. And if you sum all the exterior angle of that polygon, you will have 4 right angles, which is 360 degrees. But students, to take note that the sum of the exterior angle is equivalent to 4 right angles, or you can say 360 degrees. But interior angle plus exterior angle sum up to 180 degrees because they make a straight line. They make a straight line. And generally, the sum of angle on a straight line gives us 180 degrees. Now let's cite examples to ascertaining the definition we've already made so that we can see how we solve problems under polygon involving exterior angles. Example 1, calculate the size of each exterior angle of a regular hexagon. Calculate the size of each exterior angle of a regular hexagon. Solution. The first thing that will come to our mind is to determine or to ascertain what a hexagon is. A hexagon, by our previous definition, is clearly spelled out as any figure bounded by 6 sides. Any figure bounded by 6 sides. Now, we are expected to calculate the size of each angle of a regular hexagon. The word regular needs to be clear. Regular means a polygon with all its sides and angles equal. A regular polygon is a polygon with all its sides and angles equal. Now, for a hexagon, the sides of the polygon are 6. So we need to know the sum of the exterior angles, which we have already stated from the definition, that the sum of exterior angle of any polygon is 360 degrees. Now, we need to know the value of each of its exterior angle. The value of each of its exterior angle. So it will be the sum of the exterior angles divided by the number of sides. To know the value of each of its exterior angle, we are expected to know the sum, which is the sum of the exterior angles divided by the number of sides. The sum of the exterior angles is 360 degrees. Now a hexagon is 6. So figure bounded by 6 sides is hexagon. Now we divide the sum of the exterior by the number of sides, which is 360 degrees divided by 6. 360 degrees divided by 6. If you simplify that correct, you have 60 degrees. you have 60 degrees. Therefore, each exterior angle of a regular hexagon is 60 degrees. Each exterior angle of a regular hexagon is 60 degrees. Question 2, we are expected to calculate the value of y if the exterior angles of a polygon are y plus 20 in bracket degrees, 2y degrees, y plus 30 in bracket degrees, 70 minus y in bracket degrees, and y degrees. The question again, calculate the value of y if the exterior angles of a polygon are y plus 20 degrees, 2y degrees, y plus 30 in bracket degrees, 70 minus y in bracket degrees, and then y degrees. Take note, my student, if you observe the question very well, we were not given the number of sides of the polygon. We were not given the number of sides of the polygon. It wasn't spelled out whether it is a triangle, a quadrilateral, a pentagon, a heptagon, and any type of polygon. It wasn't spelled out. But one thing you should take notice, the question is talking about exterior angles. The question is talking about exterior angles. So it could be how many sides the polygon has. All you need to realize is the sum of its exterior angle will give you 360 degrees. So the issue of whether it is a pentagon, it is a heptagon, it is a decagon, it is a duodecagon, whatsoever type of polygon is none of our business in this case. We are expected to just sum up the value given to us and we equate it to 360 degrees. Now, the sum of the exterior angles of a polygon, any polygon outside angles sum up to 360. Now we are given y plus 20, 2y, y plus 30 degrees, 70 minus y degrees, and y degrees. If you sum them up, you have 360 degrees. Because they are exterior. Now, we will be having our y plus 20 by summing them up, plus 2y, plus y, plus 30, plus 70, minus y, plus y, equals to 360 degrees. It is a theorem, it is a fact that you should know. Now, by simplification, if you sum up all the y's, we'll have 4y plus 120 degrees, because 20 plus 30 plus 70, you have 120 degrees. How then do we find the value of y? We collect like terms. We collect like terms. You collect all the unknown in one side and then the known in the other side. Therefore, we transfer 120 degrees to the right-hand side of our equation. And you should take note that when a number crosses equality sign, it changes from positive to negative, and from negative to positive. That is why we have 4y is equals to 360 degrees minus 120 degrees. 360 degrees minus 120 degrees. We are left with 4y equals to 240 degrees when you subtract 120 from 360. Now, how do we find the value of y? The coefficient of y here is 4. The coefficient of y here is 4. And the coefficient of a term is a number that multiplies the term. So we are to divide thoroughly by the coefficient of y. So dividing through by 4, which is the coefficient of y, we have 4y equals to 240. If you divide through by 4, 4 divides 4, 1. You will be left with y. And then 240 degrees divided by 4, the answer is 60 degrees. 240 divided by 4, the answer is 60 degrees. Hence, our y is equals to 60 degrees. Example 3. The question says, the interior angle of a regular polygon is 160 degrees. The interior angle of a regular polygon is 160 degrees. The question is, how many sides has the polygon? How many sides has the polygon? Question again, the interior angles of a regular polygon is 160 degrees. How many sides has the polygon? Solution. Now, regular is a clear fact that the polygon has all its sides and angles equals to each other. All the sides and angles are equals to each other. But then our problem here is we are not spelled out whether it is a hexagon, it is a pentagon, it is a triangle, it is a quadrilateral. The number of sides we are not given. We are only told that this interior angle is 160 degrees, which means that each of its interior angle is 160 degrees because it is a regular polygon. It is a regular polygon. Now, all we need to do is to be able to find the size of each of its exterior angle. Find the size of each of its exterior angle. Because the interior angles are regular, the exterior angles are also going to be regular. Since the exterior angles are regular, we represent one of it by letter x. So let x be one of the exterior angle of the polygon. Let x be one of the exterior angle of the polygon. Now we have interior angle plus exterior angle. The interior angle inside plus the exterior angle outside makes a straight line. And from our polar geometric fact, the sum of the angles of a straight line is 180 degrees. So if one interior is 160 and the exterior is x degrees, add them up, you have 180 degrees. That makes a straight line. Now, by collecting like term, our x will be 180 degrees minus 160 degrees because positive become negative and negative become positive. In this case, it is plus 160. Going to the right hand side, it become minus 160. Now, simplifying 180 degrees minus 160 degrees will give me 20 degrees. So our exterior angle in this case, each is 20 degrees. Each of the exterior angle is 20 degrees. Now, knowing the value of each exterior angle will give you a clue to find the number of sides of the polygon, because the sum of the exterior angles of any polygon gives you 360 degrees. Now, if each exterior is 20 degrees, divide the sum of the exterior divided by the number of value each of the exterior possesses, and each of the exterior angle consumes 20 degrees. So how many of such angles are contained in 360 degrees? How many of 20 degrees are contained in 360 degrees? We will now have the number of sides of the polygon will be the sum of the exterior, which is 360 degrees, divided by the value of 1, which is 20 degrees. And 360 degrees divided by 20 degrees will give us 18. 360 degrees divided by 20 degrees will give us 18, which shows the polygon has 18 sides. Moving ahead, let's have question 4 as example. Question 4, if each interior angle of a regular polygon is 5 times the exterior angle. If each interior angle of a polygon is 5 times the exterior angle, how many sides has the polygon? How many sides has the polygon? Suggest a name for the polygon. Suggest a name for the polygon. Solution. Now, there is a condition given in the question, because the question spells out that each of the interior angle is 5 times the exterior angle. So you set some values. You set some values. Let the size of each exterior angle of the polygon be y, because it's an unknown. You can pick any letter. It could be A, it could be B, it could be C. Preferably, I choose y in this case. Then each of its interior angle will be 5 times the exterior. So if the exterior is y, interior will be 5 times y, which will give me 5y. Each of the interior is 5 multiplying the exterior angle. The good story here is the polygon is a regular polygon. The polygon is a regular polygon. Now, the fact that the interior angle plus the exterior angle give us 180 degrees is what we are going to deduce to determine the value of y. So 5y now plus y, interior plus exterior, will give me 180 degrees, because they form a straight line, and the sum of angle on a straight line is 180 degrees. 5y plus 1y is 6y. 5y plus 1y will give us 6y. How do we find y? The coefficient of y here is 6. The coefficient of y here is 6. So dividing through by the coefficient of y, which is 6, 6 will divide 6 to leave you y. We are now having 180 degrees divided by 6. 180 degrees divided by 6, the result is 30 degrees. The result is 30 degrees. Hence, the number of sides of the polygon, mark you, exterior angle is 30 degrees. Each is 30 degrees. And we are given the fact from the beginning that the sum of exterior angle of any polygon is 360 degrees. So in this case, we are indirectly asking you how many 30 degrees are contained in 360. How many 30 degrees can be found in 360? So you divide 360 degrees by 30. If you do that correct, you will have 12. So 360 divided by 30, the result is 12. Hence, the polygon has 12 sides. The polygon has 12 sides. My student, the question went ahead to say we should suggest a name for the polygon. Suggest a name for the polygon. Since the polygon has 12 sides, it therefore means the polygon is a dodecagon. The polygon is a dodecagon because a dodecagon is a polygon bounded by 12 sides. Now we deduce the number of sides as 12 that predicts the name of the polygon as dodecagon. The last example, example 5, we have the interior angles of a quadrilateral are x plus 20 degrees, x plus 10 degrees, 2x minus 45 degrees, and x minus 25 degrees. The question again, the interior angles of a quadrilateral are x plus 20 degrees, comma, x plus 10 degrees, comma, 2x minus 45 degrees, and x minus 25 degrees. The question is find the size of each of its exterior angle. Find the size of each of its exterior angle. Solution. Now, quadrilateral. Quad is from quarter. So when you divide 360 into 4, you have quarter. So a quadrilateral is a figure bounded by 4 sides. Any figure bounded by 4 sides is a quadrilateral. Now it means the polygon has 4 angles and equally 4 sides. The polygon has 4 angles and 4 sides. Now let's find the sum of its interior angle. The sum of its interior angle is given by the formula n minus 2 in bracket times 180 degrees. N minus 2 in bracket times 180 degrees. In this case, our n is 4. So we substitute n by 4. That is why we'll be having 4 minus 2 multiplying 180 degrees. 4 minus 2 multiplying 180 degrees. If we do that, 4 minus 2 will be 2, and then 2 multiplying 180 degrees, the result is 360 degrees. We have 360 degrees. Now, we were given the angles in terms of unknown. So you need to just sum them up, and it will be equivalent to 360 degrees. Therefore, we have x plus 20, x plus 10, 2x minus 45, x minus 25 equals 360 degrees. By simplification, we have 1x plus 1x, 2x plus 2x, 4x plus another x, 5x. Then 20 plus 10, making 30. And 30 minus 45 is minus 15. Minus 15 minus 25 will give us minus 40. So by our simplification, we'll be having 5x minus 40. 5x minus 40 degrees. Now we are expected to deduce the value of x. So we collect like terms. When we collect our like terms, the 40 degrees will move to the other side, the right-hand side becoming positive. So we have 5x equals to 360 plus 40 degrees. Following the rule, when a number crosses equality sign, change from positive to negative and from negative to positive. Simplifying 360 plus 40, of course, we are going to have 400 degrees. So 5x equals to 400 degrees. 5x equals to 400 degrees. Who then is x? Divide through by the coefficient of x, which is 5. Dividing through by the coefficient of x, which is 5. So 5 divided 5, 1. So we'll be having 1x, which is represented as x. And then 400 divided by 5 is 80 degrees. 400 divided by 5 is 80 degrees. Therefore, the interior angles have to be determined. You know the interior angles first before you find the exterior angle. Since we have known the value of x, we can deduce the angles of the quadrilateral. X plus 20 is the first angle. X plus 20 is the first angle, and then it will be 80 plus 20 because we have deduced the value of x as 80. So we replace x with 80 now. We will now have 100 degrees because 80 plus 20 is 100. That is one of the angles of the quadrilateral. The next angle is s plus 10, which is 80 plus 10. And 80 plus 10 is 90 degrees. The next angle will be 2x minus 45. 2x minus 45. Replacing x, it will be 2 times 80 minus 45. 2 times 80, the result is 160. The result is 160. 160 minus 45, you have 115 degrees. 115 degrees. The last angle of the quadrilateral is x minus 25. Who is x? X is 80 degrees from our calculation. So 80 minus 25, we'll be having 55 degrees. We'll be having 55 degrees. That is not all, because all we have deduced are the interior angles of the quadrilateral. But the question says we are to find the exterior angle of each of the polygon. Now, the exterior angle plus the interior angle will give you 180 degrees. So if the interior angle is 80, the interior is 80, the exterior will be 180 minus 100. 180 minus 100. That gives you 80 degrees. The next angle was 90 degrees, which is the interior. So the exterior will be 180 minus 90. The exterior will be 180 minus 90. The other angle was 115 degrees as an interior angle. So to find the exterior, subtract from 180 degrees. So 180 degrees minus 115 gives me 65 degrees. Then the last angle, which is 180 minus 55. The interior is 55, so the exterior must be 180 degrees minus 55. That gives you 125. Hence, the angles of the exterior, angles of the quadrilateral have been deduced. Hence, the exterior angles of the polygon are 80 degrees, 90 degrees, 65 degrees, and 125. They are the exterior angles of the polygon. Now, because of time factor, we'll stop here and I will give you assignment for you to practice at home so that you can study and then